Let's move on to the third question. Why does Docker container utilize the same kernel as the host system? Okay, so let me show you this. So let's go to this one. Okay, and let me show you. So I'm running Amazon Linux. Oh, sorry, we name -a. And here you can see I'm running 6.1. Whatever with the kernel version. Okay. Now let me run Docker container run -it CentOS bash. Okay. So this image is not present. So obviously it is going to pull that first image first from the Docker hub. Okay. While this image is loading and everything is happening behind the scene, anyone know why Docker is, I know this Docker does not find this CentOS image here locally, and it goes to a Docker hub for pulling the image. Anyone know why it is going directly to a Docker hub and not to any other container registry?
I think we have some repository. In the repository, we have just to look on the local, then go to the remote one.
Yes,
And
but why remote is always Docker hub? Can't it be like xyz.com or any other registry?
maybe that there is Docker's like engine we are using. So Docker hub is the, or we can change it, but I think that is Docker's engine we are using. So obviously we go to Docker.
Okay, and Mohit said default configuration for Docker hub. So where exactly that default configuration is defined? It should be on the Docker. Some file is there, but no. Okay, I can run whatever command Mohit is saying. I am going to run it. Oh, sorry, I am inside the Docker container, so I will run this command later. Okay, let's come back to the earlier question that I've asked. So, okay, I will come back to this question. This is the host system where the container or the kernel version is this one, right? Now I'm inside the Docker container. You can see that I have this ID, right? Because I use -i interactive and T for terminal. Okay. Now let me run uname -a. And I will see that I am running the same version of kernel as my host system inside the container. But if you look at this, I'm running here Amazon Linux. And here I tried to pull something called CentOS. And I can show you guys. This is CentOS, which is 8.4 completely different release. Okay. And now this is Amazon Linux. So anyone know what's going on? Like this is the same version of kernel that the whole system is running. Why Docker is using the same kernel version? Ideally, when I'm pulling this CentOS 8.4, it should have the kernel version of the CentOS.
Is it because Docker is meant to be, or container in general, meant to be lightweight, so it makes use of the host kernel and then add on top of it any OS specific libraries and applications?
Yes, exactly. I mean, you guys are correct. You, Jaideep and Mohit. Before that, let me show you with the help of one example, with one image, so that it will be much clearer for you guys. Where is my terminal? Okay. So this is one of the most popular interview question where they ask you, what is the main difference between a virtual machine and a Docker container? Okay. And whatever you guys are saying, that is absolutely correct. So if you see at the case of a virtual machine, right, you have something called a infrastructure. I mean, whatever the hardware you have, infrastructure means the hardware. And then at the top of that, you need to run a hypervisor. And on the top of that, you need to run all the guest operating system and all its dependent library and application on the top of it. And in the Linux session, we have already discussed about the hypervisor in depth, like what hypervisor, the function of a hypervisor. Like it basically is a thin layer which is going to allocate resources to your virtual machine. Now, if you look at the Docker world, you have container, right? I mean, you have the infrastructure, and then you have here something called a host operating system. And then you have a container engine. In this case, we are talking about the Docker, but we have the other container engine system like Rocket or Containerd and all those. So that is one of the reasons why Docker is lightweight, because it is not going to have its own guest operating system. It is going to use the same operating system as your host is running. And that is why the Docker container is lightweight. But that lead to a question. If in this case, we know this is a completely different operating system we are running, right? All of these. Are you seeing any drawback in this case? And other thing is, how can I make sure that this container which I'm running is not going to see, or it's not going to interfere, or it's not going to create any problem for the other containers? So how can a Linux kernel ensure that this container is completely isolated from this container, and this container is completely isolated from this container?
I think it was discussed with the namespaces and C groups. I think we can do it.
Yes, exactly. This is because the namespace is C group. But okay, I will come to the namespace and C group in just a minute. But are you seeing any issue or any advantage of using a virtual machine over the containers here? Just looking at this diagram.
In case one of our guests also OS get down, one of our app will be impacted. But in case our operating system, which is installed in our infra, get down, all our app are down. That is the one of the.
Yeah, absolutely correct. But what happens if this whole hypervisor goes down? Then in that case also, this whole guest operating system is going to be down, right?
Correct. Dependency on container engineering, but that is mandatory. Yeah.
Okay. So one thing is, in case of a Docker, so for example, here you have the kernel, like I showed you, Amazon Linux, which under the hood is running Linux, right? Here you can only put a Linux-based operating system because you have the dependency on the host kernel. Here, even for example, let's give you a simple example like a virtual box, right? In virtual box, even if you have this hypervisor which is running, even it's running on the top of a Mac or a Linux-based system, you can run a Windows-based operating system because this is a complete isolation. But here in this case, all these container is depending upon the host operating system kernel. Okay, and that's what I spoke about the Mobi project, which they are trying to do an emulation, and they are trying to run a Windows container they're trying to run a Windows operating system in case of let me start again. They are trying to run Windows on the top of a Docker, but actually they are providing some kind of an emulation where under the hood it's actually running Linux. So it's a completely different topic, but just to tell you at the high level overview, here there's a possibility, or here it is possible to run our Windows-based operating system on the top of this hypervisor, but here there is no possibility because Windows does not understand the Linux kernel, right? Any questions so far before we go to the main topic, which is Himanshu and you guys have mentioned like namespace and C group?
Yeah, Prashant. So I would just like to, can you please rephrase or just re-examine this concept again with us, because it's important concept, I guess. The difference from the, I think the emulation from where the containerized the technology has begun basically.
Okay.
Due to this.
So namespace and C group. Okay. So this is the core of Docker. The reason why the Docker container exists. I mean, whatever the CLI, whatever the command line, whatever the UI you have, this is where the whole Docker starts. Okay. Anyone wants to talk about this namespace and C group? What exactly the role of a namespace and what is the role of a C group? Namespace is used for isolation. Yeah, that is absolutely correct. And what about C group? Yeah, it's for resource control. So let me start with the namespace. Okay, so let's go back to this same drawing again. And one important concept for these Docker containers to run. So let's say this Docker container is running or this one or this one. is something called isolation. And what do I mean by this isolation? So if you think from the container point of view, so if I go back here in this machine, right, I run up one container over here. Okay. And then I spin up one more container. From the first container that I have spin up, this first Docker container, for this container point of view, he thinks that he is the only container which is running on this machine. Even I have spin up other container, Docker 2, Docker 3, whatever the containers are that I have spun. But ideally, or this should be that this container should have no idea about the Docker container 2. Okay. And this is because, let's say I am working on a shared infrastructure, right? And I'm the part of let's take a simple example of like AWS ECS service. So that's the kind of a shared infrastructure, right? So one Docker container might be from company X and the second Docker container may be from the company Y. So we don't want these two Docker containers to talk to each other because they are from the completely different companies. Just throwing you a high level idea. So once again, this Docker one thinks that he is the only container which is running on the system. And this Docker container 2, he will think that he is the only container which is running on the system. So who provides this isolation? And that is the work of this namespace. Okay. And as Naveen has mentioned, this is a construct which comes from the Linux kernel. So what Linux kernel will do is that each Docker container which is going to spin it up, and that we are going to see in one more question, it will get its own network, own file system, own process space, whatever you can think like a machine need to require to boot it. This is going to be happen with the help of this namespace. And that is how the isolation works. I mean, this is to isolate one container from other. That is the main use of namespace. Any questions so far regarding this namespace? Or if you just want to understand in one terms, it's basically to provide the isolation so that each container will run independently without impacting the other container or without to know about the other containers.
Is the isolation or namespace supported by the Linux kernel level or just the Docker binary?
It's by the Linux kernel level.
Okay, thank you.
Now, C group stand for control group. Okay. And any one of you who is coming from earlier Linux background, they know that there is something called a U limit, which is stand for user limit. So basically what it will do, so let's say in any Linux system, I have one user called Prashant. Okay. And I want this particular user, or let me extend this concept, or let's say I have a group. Group means I have a group which has consists of bunch of other users. And I want, I'm just throwing one example, should only use 1 GB of memory and 2 CPU on that particular system. Okay. And I can do that with the help of something called a U limit or user limit. Okay. But the biggest drawback of this feature that it's only applied for user or group. Okay. Let's say, again, I'm just throwing one example. Let's say I have a process and I can, okay, let's say the Chrome browser, I'm just again throwing one example, or it can be anything, Apache process or any other process. Let's say I want this Chrome browser when launched on my Linux system have the same limit, right? That cannot be possible with the help of a U limit. U limit only applies for user or for groups. And that is where this concept of C group came. C groups can apply at the level. So I want this particular process to only have this particular amount of limit. If it's try to go beyond that limit, then again we have the concept of soft limit versus a hard limit. If it's try to go beyond that limit, the kernel will kill that process. Okay, and this is for resource optimization. That they want not a single process is going to own all the resources, or your system will not run out of resources at that time. Okay, so same thing applies for C groups in case of a Docker. So Docker borrowed that concept from a Linux kernel. So if I go back, starting from kernel 2.6, which is way back, Linux kernel added this concept. I mean, this C groups comes from our Google project. Google made this project open source, and then they add this to a part of a Linux kernel. So now with the help of a C group, you can even implement at the process level. Okay. Now try to combine all these things together. Okay. So for a Linux kernel, or from a Docker point of view, Docker is nothing but it's just an isolated process. Let me write it down. So Docker containers are nothing but an isolated process. Okay. So what do I mean by that? So we have talked about it a lot, that in one of the sessions we have talked about the Linux boot process, right? And with all the stages which is happen starting from the post your power on cell test to all the way, the control hand it over to the kernel, to init, LMFS, everything. The first process which boot is called a init, right? And nowadays it's called systemd, which has the PID 1, right? And this is the parent process, and all the process will be the child process of this parent process. So let's say after that I started, like, let's say Apache server or HTTPD. So this process become a parent process, and all the process become a child process of this parent process. Okay. But in Docker, I mentioned Docker containers are nothing but an isolated process. So the philosophy behind Docker is one process per container. Right? One process per container. So let's say I want to have a container of Nginx. Okay. So Nginx is the only process which is running inside the container. And as soon as Nginx will done its work, we are going to shut down that container, or if it's managed by Kubernetes is going to take care of shutting down that container. Okay. So this is the only process which is running. It's not like a traditional system where we have the init process, and if this Apache process shut down, init will take care of the control, and it is going to take care of cleaning up all the process or all of the system resources which is associated with this process. I mean, we have talked about this in depth during our Linux session. So idea behind that Docker is like one container process, but who is going to manage, like, how much is the allocation of memory or the CPU which is being assigned to that process? And that has been done with the help of something called a C groups. Okay. And the next question which is coming up is, we are going to see with the help of practical example how we are going to control this amount of CPU and memory. So again, let me revise all these things. Namespace is for isolation. Basically, you want to isolate each container from one another. Okay. Each container should have its own PID, network space, file system, or the allocation of resources, like fixed amount of CPU and memory. But how much that will be allocated, that has been controlled by our C groups. Okay. And this is important because in a single machine, you are going to spin up a lot of containers, and you want all of them to be isolated from one another. But at the same time, you don't want one container to have all the resources of your machine. You want to limit that thing. Okay. If you are coming from the Kubernetes world, they have something called a resource limit, where we can set up a limit that, okay, when this container boots up or when this pod boots up, it only have this much amount of memory or CPU or IO or all those things. So same thing applied for Docker here also. And under the hood, they all are using the same thing, namespaces and C groups. And like I mentioned, the next question, we are going to see how we are going to control that. Any questions so far? Mohit, yes, we can run more than one process at the container, but that is not considered a good practice. So again, I'm jumping ahead. If you are thinking in terms of like Kubernetes, we have something called a sidecar container. So like one container which is going to do the main process, and then we have the sidecar which is been inserted to do the other thing. So let's a simple example for that. Let's say I have the Apache server running, and then we are going to insert a sidecar container which is going to take care of the log processing. So that container is going to take a log from the main container, the Apache, and forward the log to the some other places. Like for example, your uh, uh, what do you say, Elasticsearch or Kibana or to Splunk. Like similar to Envoy proxy, yes, I can say that.